As we discuss Earth's layers, I've got a diagram here for you, and you have your notes. Now, I didn't intentionally make this diagram to look like an eyeball, but it kind of does. But anyway, when we talk about Earth's layers, current scientific belief is that the layers formed according to density, with the most dense material being in the center of the Earth. And as we go out from the center, the layers are less dense and less dense till we get to the crust, which is the least dense of all. Now the crust is made up of two types of crust. There is continental crust, the land, continental crust, and there is oceanic crust. The continental crust is made out of mostly granite. Oceanic crust is made out of mostly basalt, which is a volcanic rock. The oceanic crust is denser than the continental crust, and it is below the continental crust. When plates move, typically continental crust will slide over oceanic crust. Now, just below the crust is the mantle. The mantle is the largest layer of the Earth. And we look at it as three pieces. We've got the mantle. Then if we look at the mantle and the crust, we call that the lithosphere. This part of the mantle, upper mantle, and the crust is called the lithosphere. And this means upper mantle plus crust. Now the lithosphere is rigid, and it is divided into plates, which we will get into more later. But the lithosphere is rigid. Now if we look at the next part of the upper mantle, the lower upper mantle, we have what we call the asthenosphere. The asthenosphere. It is the lower part of the upper mantle. Now the asthenosphere has convection currents in it. That's what these little arrows are. Convection currents in there. And the asthenosphere is like that stick of butter that we left out on the counter. The lithosphere is like the stick of butter in the fridge. Asthenosphere is like the stick of butter on the counter. So it's softer, it spreads easily, and that's actually what's going on in the asthenosphere. And there are convection currents, and we know that convection currents will move like this. On the bottom of the current, it's the hottest, then it will rise. As it rises, it cools, becomes more dense, and sinks. Warms up, rises, becomes more cool and more dense, and it'll sink. So those convection currents keep moving. These convection currents are what scientists believe move the plates that the lithosphere is broken up into. Then we have the lower mantle. The lower mantle is solid. So we break the mantle into three pieces. We've got the lithosphere, which is the upper mantle and the crust, and it's solid and rigid. We have the asthenosphere, which is the lower upper mantle, and it's like that soft butter on the counter, and that's where the convection currents are. And then we have the lower mantle, which is totally solid. Now, below the lower mantle, we have the outer core. It is liquid. It is the only layer that is completely liquid, the outer core. And in the very center, we've got the inner core, and it is completely solid. Now, why is this one completely solid? Why isn't it liquid? Well, it's completely solid because it has all this pressure of all the other layers on it. And that pressure compacts it to make it solid. If it didn't have all that pressure, perhaps it would be liquid. But because of all this pressure, it is solid. Now, what you need to do is you need to draw this out and label it, just like I have. And so that you will understand the different layers. Remember, the layers go in order of density, least dense to most dense. That's how the layers go. How do scientists How did they come to that conclusion that the layers were that way? Well, they came to that conclusion because of earthquakes. And earthquakes send out waves. We call them seismic waves. And waves, just like other waves that we've studied, they move differently in liquids and in solids. So if an earthquake happened over here and the waves went through the core, well, nothing came out over here. If the earthquake happened here and the waves went through, well,